So guys, this is kind of, it's not too bad. It's like there's a long division, but we're going to learn what's called synthetic division. It's kind of like a shortcut. Instead of doing a really long problem with a lot of variables, they have this method called synthetic division that helps you divide these like pretty easily actually. So you're going to have problems that say like 2x to the third power minus 13x squared plus 26x minus 24, something like that. And then it's going to say divide that by x minus 4. And see, that's a pretty long question, isn't it? It's like you have this long problem right here, and then divide it by x minus 4. Okay, so there is, you guys learned in elementary school long division. But we're going to do a shortcut of it called synthetic. We're going to take a long problem, a polynomial, and divide it by a binomial. So let me just show you, like, we're actually not going to do it this way, so you don't have to write the next part down. Like, I'm just going to show you, it's like this. They're asking you to do stuff like this. They're asking you to take this 26x minus 24. They're asking you to divide this. See, this is called long division, right? They're asking you to, like, take that big thing and divide it by x minus 4. Remember doing, like, long division when you're younger? But we're not going to do it that way. It is possible to do it this way, but we're going to learn, like, the shortcut way. Because this is long. Obviously, long division. So, you know, it's a long problem. Well, I'm just pointing out, guys, you can do it by long division, but I don't think you're going to want to do it that way. We go right to the shortcut way to do it. Because if I did long division, I can show you, it'd be like this. See? We're going to do the shortcut way. It's called synthetic division. So to do synthetic division, you need the numbers that are in this problem here. I'm just going to like highlight them. You need to look at the problem that you're starting with, the long polynomial that you're dealing with, and we just have to pay attention to the numbers in there. So there's a 2, 2x to the third, and then there's a negative 13. I'm just going to write down the numbers from that problem. It's a quick, shorter way to do it. And then I have 26 and negative 24. So I'm writing down the numbers from that, guys. Yeah? Yeah. So this is the short way to do it. You just write down the numbers from here, but watch the signs. There's a negative on the 13. There's a negative on the 24. And then you make like a little box out here. Yeah, it's kind of backwards. And in the box, okay, you have to put the opposite of this number in the box in the front. Yeah, you have to put positive 4 here. Opposite of that is positive 4, obviously. So positive 4 is what goes out here in the box. Okay, then you have to like leave a space under this. You have to leave a little bit of space and then draw a line under that. But leave some space. It's not right under the numbers. Draw like a space and then draw a line. Okay, so this is the shortcut way to do it. The first thing you do is just bring down the 2. That's right there. Just bring that down. Just drop that 2 down. Okay, then you multiply the number that's in the little box in the front. You do 4 times 2. And put that under the next number. So it's like this times this. You multiply those, and then put that under the next column. And then up and down, like you just add these here. You just add these here. So now you take negative 13 plus 8. You know what that would be? Yep, negative 5. And then you multiply again. The number in the box times this negative 5. And you put that under the next. See how you kind of work your way across? So you do 4 times negative 5. That's negative 20, so you put that under the next number. Add this up. Good job. You get 6. Then you multiply again. 4 times 6 is 24. Add this up. You get 0. And this last number, yeah, this is the remainder. Okay, now we need to write the answer back with, like our problem when we started had a lot of variables in it, right? So our answer does have letters in it. We just took the letters away for a second so we could do the little quick dividing. It's kind of interesting how it works. So now, the final answer, okay, you got to look at your original problem. Your original problem said x to the 3rd power. So the power goes down by 1. Like final answer, power goes down by 1. Like the problem up here was x to the 3rd power. So my final answer is going to be some x to the 2nd power problem. You get it? It goes just go down a power. So it's going to be 2x to the 2nd power. You have to like write the letters back in, but just go down 1 power from where you started. This was x to the 3rd up here. So it's going to be 2x to the 2nd minus 5. It goes down. 5x. It's always descending order. See how this went like x to the 3rd, x to the 2nd, and then x, and then no x's? It's, you know, not, so ours is going to go x to the 2nd, then an x, then just a 6. See? 2 x's, 1 x, no x's. This is the answer. There's no remainder. Remainder 0. So this is the answer. We just divided.
If there was a remainder, would we do it like how we did it in the munchies with just like the R and then the number?
No, I'll show you. We're going to do one with a remainder. A remainder is going to be like a fraction at the end. A remainder will end up being like a fraction at the end. We'll do one with a remainder. So yeah, look at that. So we got it all figured out. It's a quick method to take away the numbers. It's called synthetic division. Okay, let's try another one. Okay, so new question. All right, let's try. This one says negative x to the 3rd plus 4x squared plus 9 divided by x minus 3. Okay, new question. And the thing about this is, okay guys, now I want to get into things where you have to watch for missing terms. The one we did at the first example we did didn't have any missing terms. I'll show you what I mean. Missing terms, like this is x to the 3rd power. This one's x to the 2nd power. And I was talking about how it goes down in descending order. Like this is x to the 3rd. This one's x to the 2nd. This is x to the 1st. And then this doesn't have any x's. You know, when like 3, 2, 1, 0. Well, this one's missing something. This one has negative 1 x to the 3rd. Yeah, that's like a negative 1. And then you have 4x squared. What's it missing? It's missing an x, so you have to put 0x. You're going to have to rewrite this thing. It's missing an x. It has x to the 3rd. It has x to the 2nd. It didn't have just a plain x. So you have to write 0x. You have to like add that in. Because you can't have anything missing if you're going to do synthetic division. You have to have like all your, every power accounted for.
Can we turn off the lights? It's hurting my eyes to stare at this board.
Yeah, you can. She's asking, we're going to flip the lights off to see it better. Okay, so we got -1 here. We got a 4 here. Okay, it was missing, guys. It was missing an x. See? So we added a 0x in there. We got x to the third, x to the second. We needed an x. Okay, now we can do the synthetic division. Yeah?
For the 0x that we put in there, would we count that as 0 when we're at, like, putting it with other things, or would we count that as a 1?
You count it as 0.
Because
Yeah, we're going to use the coefficients, like the numbers in front that I'm highlighting now. We're going to use, to do the synthetic division, we're going to put -1, 4, 0, and 9. And then it's like in a box in the front, you're going to put the opposite of this number. What's the opposite of this -3? So we're going to put a 3 in the box. Okay, now we'll try this synthetic division again. So the first step is always just bring the first number down. You don't do anything. You just bring this -1 down. Okay, you bring this down, guys. And then I'll just kind of try to make a note. It's always the number in the box out here. You always multiply it with the number at the bottom. And you go over to the next column. So 3 times -1. -3. And then I'll just write on the side that then we add these columns up and down. Okay, come on guys, let's get this done. We multiply, and then we add this up. So that's 1. Then you multiply again, 3 times 1. That's 3. And then you add this up. Then 3 times 3, 9, and then add that up. Okay, now this last number is always the remainder. And so now this time we do have a remainder. We have a remainder of 18. So we'll have to show you how to deal with that. Okay, so now we got to write our final answer. So our problem that we started with was x to the third power. So I was telling you it's going to go down a power when you write the final answer. Yeah, -1x squared plus 1x plus 3. Now the remainder goes 18 over, it's going to be like a fraction. Remainder is always a fraction. It's going to be a fraction. You put 18 over what we were dividing by at the original problem. You put the whole thing, that whole thing, you put x minus 3. 18 over this divisor, x minus 3. And that's the answer. So the remainder is a little fraction at the end. 18 over the x minus 3 from where we started.
Is this all our homework's going to be?
There's one more example. There's one more different kind. There's ones that say evaluate. I'll show you. Yeah, pretty much. Yeah, like they're all pretty much like this. So they're not too bad, guys.
Is it on paper or on computer?
It's out of the book. It'll be out of your ebook.
Well, I can't do that.
Okay.
I have another question.
Yeah.
For that one, why did we write the degree, the negative right now for the
Okay, so guys, the remainder, it's always going to be over what you were dividing by, what the problem said at the beginning. It's always like divided by this. You know, if you were doing he was asking why does this go here? You know, if you were doing like a long division, or if you were dividing something else, Like if you were dividing 12 divided by 5 or something like that. It's, 5 goes into 12 twice, and that's 10, and it's a remainder of 2. You can put the remainder 2 over this. So it's like 2 2/5. If you were dividing regular numbers, it's always like a fraction like this over 5. And we're dividing by this. We were dividing a big problem by x minus 3, so the remainder always goes over what the divisor was. Yeah, it always goes over what the original problem said, what you were dividing by.
And then why didn't we do it the first time?
Because we got 0 as the remainder.
Oh, okay.
Yeah, the first time didn't have a remainder 0. Okay, now let's do one last kind, evaluating. Like, if they ask you to evaluate a function. So we'll have to go here, I'll fix my... Let me look at this one. Okay, so they have one in the book, use synthetic division to evaluate a function. Okay, so it'll say evaluate f of x equals, and this one says, let's get the equation written out, 5x to the third minus x squared plus 13x plus 29. So they say to evaluate this when x equals -4. All right, let's get this all set up so you can see it. Evaluating. Okay, it'll tell you to evaluate a function, and then they'll give you a number when x equals -4. Okay, notice they didn't, they're just giving you a number. They're not giving you like dividing by something. It's not like dividing by a little tiny problem. It's not like dividing by x minus something or x plus something. So it just says evaluate this when x equals -4. You can use synthetic division to evaluate something. So it's like I'm trying to find f of -4. It's like instead of plugging that in, you can use synthetic division to solve it. So the -4 number, this time you don't have to do the opposite of it because it's not written as a little problem like x minus or x plus something. You can just put -4 in the box. You don't have to change the sign to opposite because they just tell you to try this number. And we're going to do the same thing, synthetic division again, with this long problem, and it'll give us the answer. It's kind of cool. So this is a negative. This one's 13. Are you missing anything? We got x to the third power. We have x to the second power. We have an x here. Are we missing any terms?
No.
So it's all set up good. We can just try to divide it, try to do it. So 5, I'm going to write down the numbers from our equation. We got a 5. This is -1. We got 13 and 29. So you can just do synthetic division, divide by -4. It's kind of weird. It says we're dividing, but we're not even doing any dividing on this. We're doing multiplying and adding. So it is kind of weird, but it actually divides. So we bring this 5 down. So try to remember, you always just bring this down. Then you go multiplying and adding up and down. So I multiply this times this, it's -20. -21. Now I got to multiply this times this.
And you get 84.
Yeah, you get 84.
388.
And then we add this up, 97, right? Now I grab my calculator, I got to take -4 times 97.
388.
Okay. No. So we got -388. Now add this up. Let's see, -388 plus 29. -359. Okay, now this time it's different. This time it didn't say to divide the problem. It said to evaluate it when x equals -4. It's like we're finding f of -4. And so what's kind of interesting about this is this remainder is the answer to the problem, -359. that's the answer. Like the answer, if you plugged in -4 into that problem where all the x's were and did it that way, you'd still get -359.
Basically, your remainder is your answer.
Yeah, the remainder is the answer.
So could we just plug it in there and get the answer like that?
Yeah, but sometimes they're going to want you to show how you can do synthetic division to get it. Yeah, like if I took a calculator and I did 5 times -4 to the 3rd power, and then I did minus -4 squared, and then plus 13 times -4, and then plus 29, you should get the same answer. Yeah, -359. See, it shows that you can do the synthetic division and get the same answer as if you plugged in the number.
But the guy would assume you want us to do this.
Yeah, they want you to show how you can do it this way. Yep. Yep, so the remainder is the answer. So like the remainder is the function value, is like the function answer, function value. Yep. The remainder is the function value.